Before we discuss the type of polynomials, it is very important to understand certain concepts related to polynomial, certain terms related to polynomial. What are those terms? The first very important term is the degree of a polynomial. What do we mean by degree of a polynomial? When we think of degree, we think of exponent or power. So, degree of a polynomial is nothing but the highest power of a variable in the polynomial. For example, if a polynomial has one variable, the highest power of the variable is called the degree of the polynomial. So, in case of a polynomial in one variable, suppose we have taken only a polynomial in one variable only, and we have studied till now polynomial in one variable when we were studying it as fx, where the one variable was x. Example, root 2 minus y cube plus y raised to the power 5 plus 2y raised to the power 6, which is not written in proper order, because when we rewrite the polynomial, we will write it in decreasing power of y. But here we have to write the degree of the polynomial. I will not look at the first term or the second term or the third term. I will look for the highest power of the variable y. The highest power of the variable y is 6. So, the degree of the polynomial is 6. In 6x plus root 3, the highest power of the variable x is 1 and it is a polynomial of x in degree 1. This is when we have only one variable, but what if we have two variables? I may have a polynomial as ax plus by plus c or ax square plus bx plus c. In case of a polynomial in more than one variable, which consists of more than one variable, the sum of the powers of the variables in each term is taken and the highest sum so obtained is called the degree of the polynomial. Little confusing, let me clarify this using an example. Suppose we have the first example as 3x square, 3x cubes minus 7x square y square plus 8. The two variables involved here are x and y. But how do we find the degree? To find the degree, I cannot take the first term because it consists of only one variable x. So, I have to take the next term which consists of both x and y. The term is minus 7x square y square. Here the power of x is 2 and the power of y is also 2 and the sum of the power is 4. So, 4 is the degree of the polynomial which is obtained by adding the highest degree of both the variables in a term. Again, explaining with another example, 8 into a raised to the power 8b plus 4ab plus root 2. Here both the terms, unlike the previous example, are containing a and b. Let us add the variables of add the powers of 4ab. Add the powers of the numbers a and b or the variables a and b. A is having power 1 and b is also having power 1. So, the sum of the powers is 2 in 4ab. The sum of the powers in 8 a raised to the power 8b is 8 plus 1 9. So, the degree of the polynomial will be 9. I will not take the sum 2, I will take the sum 9. So, again I am repeating, in case of two variables, we have to take the sum of both the variables in each term and we look for the sum which is highest, which gives us the degree of the polynomial. Now we can discuss types of polynomials, because now we know what is degree of polynomial. It is very closely associated with types of polynomial. The degree of a polynomial categorizes the polynomial into different categories. First, linear polynomial. A polynomial whose variable has the highest power 1 or a polynomial of degree 1 is called a linear polynomial. Why it is called a linear polynomial? Because when I represent the same polynomial on a Cartesian plane, I will always get a straight line. So, straight line, that is why the word linear. X plus root 7 is a linear polynomial in x, because here the highest degree is 1. The degree of the polynomial is 1. Root 2 mu plus 3, where mu is a Greek word which is used as a symbol and the power of mu is 1, is again a polynomial in mu and it is a linear polynomial in mu. Quadratic polynomial, a polynomial is said to be quadratic if the degree is 2. That means the highest power of the variable, as we can see in the example, x square plus 9x minus 32, the highest power of the variable is 2, that is why it is a quadratic polynomial in x. Cubic polynomial likewise will be a polynomial where the highest power of the variable will be 3. So, explaining with this with an example, ax cube plus bx square plus cx plus d is a cubic polynomial in x, as where a, b and c are constant values. Now, there is some characteristic which is reflected in each type of polynomial. What is that special characteristic? We have learned about the degrees and the different type of polynomials. We know the connection between the degree and the type of polynomials. If the degree is 1, it is linear. If degree is 2, it is quadratic. If degree is 3, it is cubic. There is yet another relationship between the degree and the terms in a polynomial. The number of terms and the degrees. If we closely observe x plus 7, how many terms it has? It has 2 terms. If I closely observe x square plus 9x minus 32, where the degree is 2, the number of terms is 3. Again, if I see ax cube plus bx square plus cx plus d, which is a cubic polynomial, there are 4 terms. So, what is the connection? We can very easily see number of terms in a polynomial is always 1 more than the degree? No. If I say always 1 more than the degree, it will be wrong. So, I will write maximum number of terms. Maximum number of terms in a polynomial is always equal to n plus 1, where n is the degree of the polynomial. Now, why did I use the word maximum? For example, if I take a quadratic let me start with a linear polynomial. X plus root 7 is a linear polynomial and there are 2 terms. This is my first polynomial fx, a linear polynomial. But fx could also be equal to x, which has only 1 term. It could be x plus 0, which is nothing but only x. And I told you that the terms vanish just because of the constant value. So, here I may have 1 term also, but maximum I will have 2 terms. The number of terms will not go beyond 1 more than the degree. If it is a linear polynomial, at most I will have 2 terms and at least I can have 1 term. It will not be 0 also, because since it is a function in x, the highest power is 1. So, x with power 1 also has to be there. So, it can be 2 or less than 2 or 1, but not more than 2 or not less than 1. Again, if I take an example, another example, if I take the second one of a quadratic polynomial. In this quadratic polynomial, as I can see, there are 3 terms. So, fx is equal to x square plus 9x minus 32. The degree of the polynomial n is 3. N is 2. The degree of the polynomial n is 2. So, the number of terms will be 2 plus 1 equal to 3, which is the maximum number of terms it can have. It cannot have more than 3 terms, and obviously it cannot have less than one term. So, a polynomial will have at least one term carrying the highest power of the variable. So, what did we learn? That a polynomial, the degree of a polynomial is determined by its highest power, and the number of terms at most is equal to one more than the degree of the polynomial.